So let's go to a clean page. So if I take the sum of the moments about point C, the 600-pound force causes a clockwise negative moment about point C, and the perpendicular distance is the 3 feet plus the 4 feet, 7 feet plus 5 feet, so it's 12 feet. The 7,500-pound force creates a clockwise, so negative. Perpendicular distance to point C is 5 feet. Then we can solve for 2NB, which is called a counterclockwise, so it's positive, so it's plus. The perpendicular distance there is 4 feet plus 5 feet, so that's 9 feet. And last but not least, the T, the pulling force, which is given as 400-pound force, the perpendicular distance there is 2.5 feet. Solving for NB, you get so now we have one unknown left, NC. So we take the sum of our forces in the y direction, set it to equal 0. We have our 2NC plus the 2NB, but we now know the NB. So it's 2 times 27-pound force minus the 7,500-pound force is in the negative y direction, minus the 600-pound force equals 0. Solving for the NC, you get NC 1622-pound force. So we know then that the maximum friction force developed, say, at each of the rear tires and the ground. So we say maximum friction force is the mu S times NC. Mu sub S, static friction, times the NC, which is the normal force at the tires. We calculated NC, and mu S was given as 0.4. We said NC was 1622. Therefore, F max £649 force. Well, we calculated our FS to be 200-pound force. So F max is greater than Fs. Therefore, the rear tires will not slip. All right, take a look at another problem. Problem 444, same page. Here, it says the mine car and its contents have a total mass of 6 megagrams. Mega, 10 to the 6. Center of gravity at G. If the coefficient of static friction between the wheels and the tracks, they give you mu s, 0.4, when the wheels are locked, find the normal force acting on the front wheels at B and the rear wheels at A when the brakes at both A and B are locked. Does the car move? And they're giving us the pulling force of 10 kilonewtons. So as always, let's start with our free body diagram. So we said the mass is 6 megagrams, which is 6 times 10 to the 6 grams, which is 6 times 10 to the 3 kilograms. So then the weight of the mine car six times 10 to the 3 kilograms times 0.81 meters per second squared. $58,860 newtons. So let's start with our free body diagram. The center of mass, center of gravity at G, and that's where the weight is applied. So it's 58,860 newtons here. We have our normal force we have our pulling force. This is 10 kilonewtons, so it's pulling to the left. The distance here is 0.6 meters. And distance here is 1.5 minus 0.6, so that's 0.9 meters. The distance here is 0.9 meters plus the 0.15 meters. So that's 1.05 meters. The 0.15 meters is shown on the wheel A. Okay, I think that's everything. Let's go to a clean page. Let's get this image so we don't have to redraw it. All right. So if we take the moment we have, if we take the moment about, oh, we left off our friction. One more thing. So it's pulling to the left. So we have a frictional force here. We'll say F sub B, and a frictional force here, F sub A, that is resisting the movement to the left between the wheels and the track. Now we have everything. So if we take the moment about point B, the NA causes a counterclockwise, so positive moment about point B, perpendicular distance being 1.5 meters. The weight causes a negative, so that's minus newtons times the perpendicular distance, which is 0.6 meters. The 10 kilonewton pulling force causes a counterclockwise, so positive. Perpendicular distance there is 1.05 meters. Solving for NA, you get 16,500 newtons. Therefore, solving for NB, some of my forces in the y direction. You have your NB minus your 58,860 newtons plus your 16,500 newtons. Add these two, subtract to the other side. You have NB equals to approximately 42,300 newtons. So, with that being said, go to another page. So then at each wheel, say front wheel at point B, we'll say when locked, as the problem said, then your friction, let's see, your maximum friction at point B, the front wheel, is your mu sub S times your normal force at B. (0.4 times N sub B and your FA max, mu sub S times N sub A, 0.4 times 16,500 newtons. Solving this out, you get FB max equals to 16,920 newtons. And friction at point A is 16,500, 6,600 newtons. So you can clearly see at this point that the friction is already far greater than the pulling force of 10 kilonewtons. So the mine car does not move. And we'll stop here for today. If there are any questions, please do not hesitate to send me an email. Have a safe day. Thank you.